clock. So I am going to count you in, and we will go live in 5, 4.
Right, brilliant. Hopefully everyone can hear me okay. We are, as you've just heard, we are currently live on Facebook and YouTube as well as here. So please make sure you're asking questions throughout of it. But firstly, good afternoon, everyone, and thank you so much for joining us for the Open University's British Science Week 2024 lecture. We're lucky enough to be joined by Annie Lennox, who'll be giving a fascinating lecture on her current research and exciting projects that she's working on. Annie is a final year PhD student with the Open University, which has gone incredibly quickly from my point of view, maybe less so from hers. With a background in terrestrial geology, Annie has transitioned into the planetary sciences, specifically looking at the planetary Mercury. Her PhD focuses on geologically mapping Mercury's south polar quadrangle, aka the Bat quadrangle, or H15. Alongside mapping, Annie also researches ejecta patterns on Mercury and small-scale effusive volcanism. Outside the project, Annie is an active science communicator and involved in many outreach initiatives. She is committed to improving diversity within science, with most recently has led her to investigate the effect of historical societal issues on equal representation in space science, nomenclature or naming of planetary features. So today, Annie will be giving a talk on the geological mapping of Mercury. And I thought, hear someone's got no sound. Can anyone else hear me? Hopefully you can still, other people can still hear me. If you can't hear sound, it might be worth leaving and then coming back out again and then rejoining. But today, Annie will be giving a talk on that mapping of Mercury and the naming features of the solar system. And if you have any questions, please add them in the chat. So even if you're on the chat on Facebook or YouTube, we have people monitoring those, and we'll be able to ask them at the end. So without further ado, let me hand over to Annie, and hopefully everything's ready to go on your end.
Excellent. Thank you very much for that introduction. I will take just a minute to get my slides shading. Let me know you can see them okay. There we go. That should be it now. Everything looking good?
Looks great.
Excellent. Cool. Thanks very much. Well, hello and welcome to you all. Thanks so much for coming along, tuning in, whether you're on Teams or joining us on our live streams. I hope to chat about a couple of things today. Firstly, to get you up to date with the geology of Mercury and the exploration history of the smallest planet in our solar system. I hope you'll agree by the end that it is small, but it is mighty. I am going to touch on how we map planets. The process really is fairly similar, whether you're looking at Mercury or really any other planetary object. It involves a lot of really beautiful images, a fair bit of colouring in and imagination, and of course, close scrutiny of the planet's surface. Inevitably, when you're closely looking and analysing a surface, you're going to find some interesting things, and quite often those things might require a name. And so I'll also touch on those naming features across the solar system and the representational issues that might come alongside that. Thankfully, you've already heard much of the introduction about me, but hello, I'm Annie. As my accent suggests, I am originally from the northeast of Scotland, in a relatively remote area that I was really surrounded by incredible geology, rocks and mountains, and it really spurred my interest in geology and the evolution of our planet and other planets. For my education, like Alice said, I came from a background in earth science, or terrestrial geology, and I'm now a final year PhD student with the Open University and have sidestepped into that world of planetary geology, specifically the planet Mercury. Now let's dive into some of the science. That image that you're seeing there might be a fairly familiar view to some of you. This is actually an image taken by my supervisor, Dave Roddery, from his back garden at kind of dusk time. It's 3 planets that we can see from here on Earth just with the naked eye. The bright object in the left is Jupiter, lower in the sky is Venus, and right up at the top there in the right-hand corner is Mercury. It is, however, pretty difficult to see from Earth, and that's because of its close proximity to the sun. It's really easily obscured by the light from our star. The best time to see Mercury actually is dusk, like this photo, or dawn. In fact, in ancient history, the Greeks and Egyptians thought that the dusk and dawn versions of the stars were two separate planets. The Greeks called the morning star Apollo and the evening star Hermes, and it wasn't for a while afterwards until they realised this actually was one very quickly moving planet. Its modern name, Mercury, is the Roman name for Hermes, who is messenger of the gods, and like the planet, famed for quick travel. So, some facts about Mercury. It's got an elliptical orbit of the sun. This means it doesn't move around the sun in a perfect circle, but rather follows a more elongated, kind of egg-shaped trajectory. At its closest, it is 47 million kilometres from the sun, but it can be as far as 70 million kilometres away. It takes Mercury 88 days to complete that orbit, travelling at a pretty impressive 47 kilometres per second. But it spins on its own axis relatively slowly, resulting in this really weird phenomenon, actually, that a solar day on Mercury, that's one full day and night cycle, takes longer than a year on Mercury. One solar day is 176 Earth days, which I think is really cool. As I said, Mercury is the innermost planet in our solar system, and as you can see from this little image at the bottom, it's the smallest of the terrestrial planets. The terrestrial planets being Mercury, Venus, Earth and Mars, all of which are made of silicate rock and metal. All of these planetary bodies have interiors that consist of an inner core, and then which may or may not have a liquid layer. For Mercury it does. Then you have a middle layer mantle and a thin outer crust of rock. Mercury is approximately just a third of the size of Earth, and it's in fact only slightly larger in size than our moon. There are some moons in our solar system that happen to be bigger than Mercury. For example, Ganymede, the biggest moon of Jupiter, or Titan, the moon of Saturn, both are bigger than Mercury. Looking into its internal structure, you might notice that despite its small size, Mercury has this really large core that's actually almost as big as Earth's core, and that makes it the second densest planet in our solar system. Now, that internal structure may actually help us understand a bit about Mercury's formation. There is one theory that very early in Mercury's history, it may have collided with another very large object, a planetesimal. And you can kind of see, as this diagram suggests, that impact may have stripped away some of Mercury's mantle and certainly crust, but may have preserved some of its more dense, deep core. So that's its interior. What do we know about Mercury's surface? We know that it's hot. Of course it is. It's so close to the sun. Mercury has practically no atmosphere, though, which means that there's nothing to stop that heat from escaping. And this results in a really extreme temperature change from 430 degrees down to minus 180. This video that I'm hoping should start playing for you now is an image of Mercury in enhanced colour. This is the full globe. The enhanced colour means that those blues and reds have been made brighter, and this really helps identify albedo features. These are features that have a distinctive ability to reflect sunlight. As you can see, there are many, many impact craters, these formed by meteoroids or comets, again, impacting the planet's surface. And this process has been going on since Mercury's formation 4.6 billion years ago. Some craters, you can see around the edges, are bringing up dark blue material. This is material that has come from deep in the crust. Others have these very impressive light blue ray systems. These are the youngest craters. And some still have some bright yellow floors. If we give it a wee second, I'll show you the Caloris Basin, which should just be coming up. Here we have it with its very bright yellow floor. This is actually indicating that at some point the floor of this crater was flooded by lava. The Caloris Basin is the biggest crater on Mercury at 1,300 kilometres in diameter. Additionally, we can see other than crater features, we can see tectonic features. These are tectonic faults, some of which extend several kilometres, several hundred kilometres high. In fact, you can maybe see it better in the background images. You can see this kind of linear to lobate scarp-like feature. And so those are tectonics. They're understood to have formed in response to Mercury's cooling core, which essentially has caused the planet to contract and pretty much shrink. Now, if we look at the surface composition of Mercury, the crust is volcanic, meaning that these plains were all at one point plains of lava. However, can you see any volcanoes? I'm hoping that you're all shouting no to your screen, because in fact there are no fully confirmed volcanoes, those being mountains that have been built by volcanic eruptions. So while we know quite a lot about Mercury, there is still so much to learn. Sadly, Mercury is the least explored terrestrial planet. So this timeline of exploration that I'm about to line to you is not particularly long. Here we have the state of the Mercury maps from the 18 and 1900s. Now that's all relied on Earth-based observations. And as I said, Mercury can only be seen lone in the sky and has to be viewed against both the glare of the sun and through Earth's own atmosphere. And so these conditions make for not particularly accurate maps. We have pale and dark regions that supposedly reflect albedo features, but unfortunately, now that we've seen Mercury, they don't actually reflect any surface features on Mercury. So mapping became decidedly more accurate after the first mission to Mercury, which was NASA's Mariner 10. It launched in 1973 and completed 3 flybys before it was pulled into orbiting the sun, which weirdly potentially it is still doing to this day, though we haven't heard from it since 1975. The image that you should be seeing now is of the globe as it was imaged at this time. Now, they only managed to image around 75% of its globe, and that's because the same side of Mercury was always being sunlit during the 3 flybys. And of course, the same side was always not in the sun. So they didn't quite manage to image the whole thing. But it was the first proper view of Mercury. So looking ahead to the more recent history of exploration, there's actually only been one other completed mission to Mercury since Mariner 10, and that is NASA's Messenger mission, which launched in 2004. Now, alongside Messenger gathered data, there was also some Earth-based radar, which revealed these bright reflective material at Mercury's poles, which is highlighted in this image here. So these were targeted as areas of interest for Messenger and are now generally understood to be water ice deposits, which I think is really cool. There's water in these ice in the form of ice at Mercury's poles. These usually exist in craters at both the north and south poles of Mercury, which never see the sun. These are in permanent shadow, and so within these, temperatures of minus 170, 180 are maintained over geological time. So, more about Messenger. It had an 11-year timeline, which involved 3 flybys of Mercury before collecting data all the way up into 2015, at which point it crashed into Mercury's surface. Messenger really made countless discoveries and, importantly, was able to image all of the planet's surface. So this was our first time seeing the whole thing. It imaged it in both colour, as I showed earlier, in enhanced colour, and in black and white. And pretty much all the images of Mercury that you're going to see in the rest of this talk were all obtained by Messenger. So, what's next for Mercury? Well, in 2018, we saw the launch of Bepi Colombo, and it's the next mission headed to Mercury. So this is very much the future of Mercury exploration. Bepi Colombo is a couple years into its 7-year journey. It's due to arrive in Mercury in late 2025, which doesn't feel far away at all. I'll pull up here now an image, here we go, of Bepi's second flyby of Mercury, which happened in June just of last year. Its closest approach at this point was just 900 kilometers from the surface. So it's a real nice way of seeing just how close we are. The spacecraft is made up of 2 probes, one by the European and the other by the Japanese space agencies, and it's got a whole range of things to investigate. But myself being a mapper, the one that I'm most concerned about is this one, all about surface processes, as that's the most pertinent to geological mapping. So, mapping on Mercury. Well, for mapping purposes, Mercury is divided into 15 quadrangles, all of similar size. Quadrangle's a bit of a weird name because they're not actually very square. In fact, my area is a perfect circle. But there's 15 of them, HO1 here in the north, down to H15 in the south. The mapping of these quadrangles was started in 2013 and needs to be finished before Bepi arrives at Mercury. So that's a nice little sand timer of time that we've got to complete this. It's very much an international effort, and my contribution is H15 down in the south here. And I'll show you if this moves forward. Here we go. This is H15. You're seeing 2 things here. On this side, we have the only published map of H15. This was made in 1990, before I, and I'm sure many people listening might have been born. And as you can see, because of the same side being beyond the sunlight each time Mariner 10 passed, it's only half complete. The video you're seeing here is all the different illumination conditions that you get during one solar day at Mercury's south pole. The eagle-eyed among you might notice that when the sun gets to certain positions, as it's about to here, it looks as if it slows down slightly, reverses before carrying on its journey and continuing to set. This is because, as I was speaking about earlier, the Mercury has a 3-to-2 orbit resonance, spin orbit resonance. Again, that means for every 2 orbits of the sun, Mercury rotates on its own axis just 3 times, and so it has this funny little effect. So, what's involved in geological mapping? We create these maps to identify different rocks and rock types at the surface, sometimes to try and work out what's going on below the surface even, and to also understand the shape and the history of geological features. Now, geological units on planets such as Mercury, where we only have remote sensing data at our disposal, is slightly different to geological units on Earth, and that's largely down to the fact that we don't have physical rocks that we can analyse. We can't actually go up to the rock and see what it is. So the distinction between rock units are usually based on morphological characteristics and stratigraphic relationships. That's a fancy way of saying we consider the smoothness or the texture of the unit, also its spectral colour, and perhaps the different ages and age relationships of both the ground and the surface features. So the images you're seeing here are roughly the same scale. They're the 2 main units on Mercury. First, we have the smooth plains. As the name suggests, these are characterised by untextured surfaces and have relatively fewer impact craters that have hit them. Craters can be quite well used to date areas of land on Mercury. The idea being that the longer that the land has been exposed, the more opportunity it's had to be hit by craters. So with these smooth plains, where there are very few craters, we interpret these as the youngest unit on Mercury. Now, when we say young here, we mean that the lavas that were put there between 3.8 and 3.5 billion years ago. So it's still quite old. But in comparison to the intercrater plains, here we have a much greater contrast in texture. These are far more rough with more heavily cratered as well. And so these are interpreted as the oldest areas of land, and they're also the most widespread unit on Mercury. This is aged between 1.4 and 3.8 billion years old. So while those are the two main geological units, it's not the only things we map. The craters themselves cover such a vast proportion of the surface that crater and crater materials are in themselves considered a geological unit. The different colours of craters that you're seeing in this image here actually reflects different ages of craters. And this is what the mapping process looks like. We start with a base map. Now, this is how it starts when you're looking at Mercury or for many other remote sensing planetary mapping opportunities. You have a base map like this. This again was collected by Messenger. To this, we add lines all over it. We draw, picking out for example, the crater rims, the material that's been ejected by an impact, the tectonic features like those scarps I mentioned earlier, and the boundaries between the different geological units. And lastly, when all those lines are done, we colour the whole thing in and produce something that looks a little bit more like this. Now, one of the coolest things about mapping, I think, is that you might discover some new and interesting things. And of course, when you make these discoveries, they may require naming. So with that, I'd like to introduce you to the Nairn crater. This is the first crater I ever named, which was super exciting. The crater itself is scientifically interesting. It has very unusual ejecta called lobate ejecta. Ejecta is the material that is excavated during an impact. And as you can see in this enhanced colour image in the top right here, that ejected material has a spectral signature. You can see it's very bright yellow material. Now, I really wanted to name my first discovery after a Scottish woman, because I really do think it's important that we all feel represented within our scientific systems, and that we see a little bit of humanity in the science that's being done. But the naming process has kind of brought to light, to me at least, some issues with regards to representation across the solar system, but Mercury included, and Mercury was very much my gateway into this. Before getting on to that though, I'd like to introduce you to Lady Carolina Nairn, who you should have a little image of popping up. She was a Scottish poet and songwriter who, at that point, she was a lady, and it wasn't really proper for a lady to be a poet, so she always published under pseudonyms. And so many of her poems were wrongly attributed to Robert Burns and for other contemporaries at that time. And I think there's some real poetic justice that she didn't receive the recognition she'd served in her own time, and now she receives a little bit of recognition up in Mercury. But back to the issue. Hopefully you're a little bit more familiar with this being Mercury's south pole. This is my mapping area H15, also called the Bach quadrangle, and affectionately sometimes called Mercury's backside. I hope you are giggling to that and not rolling your eyes, but either response is valid. As you can see, there are 40 named craters in this area. Only 6 of them have been named after a woman, and half of those were named by me. And I think it's inevitable that when women are missing from the narrative or from our scientific systems, other marginalised groups almost certainly will be impacted. And you can see that that's reflected in the diversity statistics I've collected for both race and nationality. They are equally, if not more so, imbalanced. So I wanted to investigate this further, which involved me manually going through each crater on Mercury and trying to work out the gender of that individual. I started off just considering gender because this really was quite a mammoth task, and I needed more help if I was going to approach this from different diversity angles. But sticking with gender for the time being, I found that at the time of writing, 51 out of 416 craters were named after a woman. That's a little under 12%. Now, craters on Mercury adopt the names of famous artists. Now, it's all forms of art. It can be musicians, there are painters, there are choreographers, there are authors, any type of art. I believe that 12% irrefutably does not reflect women's contribution to the entire history of art. And so this has prompted me to think of a couple of different routes of thought. Firstly, what's causing this gender imbalance? And secondly, is this unique to Mercury, or do we see it elsewhere across the solar system? So, sticking with that second point, and a gender focus again, I've explored these statistics for Mercury, Mars and the Moon, and at some point, if I have time, which I think I do, we'll touch on Venus as well. As you can see, diversity, unfortunately, for Mars and the Moon is even poorer. For craters that are named after people on both of these planetary bodies, only 2% are named after a woman. Now, part of this is to do with the convention. Instead of naming craters after artists, these get the names of famous scientists. And of course, historically, science has been known for being fairly exclusionary. But let's try and address some of the reasons as to why we might see a gender imbalance. Firstly, it could be a function of the time at which things were being named. Perhaps Mercury has the best in terms of representation, though still, in my opinion, extremely poor, because it being, as I said earlier, relatively unexplored. And as a result, all the naming has occurred in relatively recent times when the scientific community itself is more diverse, the logic being that more female scientists may be more inclined to name features after other women. And it's also during a time where gender and cultural diversity is slightly more at the forefront of the scientific community. Now, there is an argument that perhaps gender or equal representation is not necessary for these planets because we women have Venus, where all features should adopt a female name. Firstly, I want to open the dialogue to see if whether this stark segregation between male-populated and female-populated planets is in itself a little problematic, as it does institute and maintain a gender binary, in many ways perhaps excluding non-binary or trans candidates. Furthermore, the women that appear on Venus do not have to be real. In fact, what I mean by that, the majority are not real. I found that only 38% of craters on Venus reflect real women who made real contributions to society. The majority of craters, rather, adopt the names of goddesses or mythical characters who are more often celebrated for their beauty or for their fertility rather than for their contributions, or they have arbitrary, typically female first names. There's an Abigail crater, there's a Lucy crater. These don't celebrate any one person, but rather they're just arbitrary names. Now, I understand that the naming process is for scientific need and it's not to celebrate that individual. However, I do believe it matters who is represented. When a feature is named after a person who is of a certain gender or nationality or sexuality or religion or whatever form of diversity, people who also identify with that community, whether they're in science or beyond, will feel personally represented. Our community values are very much embedded in our scientific systems, and diversity and inclusion are now supposedly at the forefront of our scientific community. And so why do we tolerate a lack of diversity in things like our nomenclature? Now, at this point, I should introduce the International Astronomical Union, the IAU. This is the organisation that deal with name requests when you want to name a feature. They also set the conventions. Conventions dictate the themes from which names may be picked. It's the reason that all craters on Mercury are named after famous artists, and craters on Mars and the Moon adopt the names of famous scientists. Though craters are usually named after real people, that's not always the case. Not all features are named after people, and so across the solar system we might see the names of geographical locations here on Earth, or even geographical locations associated with Celtic mythology. We see different languages adopting the words for snake or for sky. But however, there's almost always, no matter the convention, some sort of implicit bias. So what is it that's the issue with the conventions? Firstly, and I think perhaps most importantly, when a real person's name is to be used, that person must be A, famous for 50 years, B, dead or deceased for, I think, 3 to 5 years at least, and C, demonstrably famous or well recognised, although they never actually define what they consider famous or well recognised. Anyway, that's another point entirely. But what these conventions do is they put weight on historic celebrity status, which inherently disadvantages women and marginalised people, regardless of the field. When we look back into history at who was able to achieve those metrics, those being fame, recognition, status, that is not a diverse pool of people. And that's because this is an inequality that is a product of a historical society structure set by and set to benefit the patriarchy. The current conventions very much go with the grain of that structural bias rather than try and be reparative. So to try and combat this, I've done a couple of things. Firstly, I wrote a letter, an open letter addressed to the IAU, explaining some of the issues associated with the current conventions as I saw them. Of course, if you have more ideas, I would be absolutely delighted. I would welcome hearing these. And if you're interested in reading that letter, please do so on the QR code that's at the top of the screen there. I also, little plug for myself, I really excitingly got a Nature Worldview publication pretty recently on this matter, which again, if you're interested, I totally encourage you to read. Additionally, I have organised 2 in what will be, or what is, a series of data entry hackathons with the aim of investigating all of the named features across the solar system to reveal exactly who is overrepresented, underrepresented, and perhaps missing entirely from space science. This involved bringing together people both in person, like these smiling faces in the bottom here. This was the hub at the Open University, but it's also it's a hybrid event. It's happening online as well. And over a weekend, we brought together these people to research the people, the places, and the cultures behind the names in our solar system. Ideally, this database will be made public on completion, and I really hope that the IAU might integrate this with their own list of named features. I'm very much, as I said, aware that this is not just an issue of gender, and so that hackathon really does aim to explore all types of diversity. And if you're interested, and I hope you might be, you can be involved, and I really would love you to be involved. We've got our 3rd and perhaps final event happening just next month, very excitingly. But I thought I'd share with you some of the preliminary results from the first hackathon. So, sticking with gender and creators on Mercury, you can see kind of, I think, in this graph how missions have influenced the numbers of creator names, which I think illustrates this quite well. More recently, in this messenger era, you can see that there has been a bit more of a decided effort to name more things after women, which is great, but it's not coming even close to that initial gender imbalance that was formed during the Mariner 10 era. Sticking with Mercury, but moving away from a gender focus, this is the research we've done into the nationality and geographical distribution of names on Mercury. Firstly, by continent, as you can see there is an overrepresentation of Europeans, and we can break this down a little bit further to look at it by country. So what we learnt, Mercury is mostly populated by cis, white, Italian men. So I think that covers most of the things I wanted to chat about. Improving diversity in science really is something that I am passionate about, and I hope you are too, and that's kind of why you came to this talk today. If that's the case, I really do want to hear your thoughts. I really do want you to be involved in the hackathons. Like I say, anyone can take part. All you need is access to a computer for the weekend and I suppose an interest in the topic. And so if you're interested and think that that's something that you might want to take part in, here's my email. There's going to be another email for SBS at the OU dropped in the comments later. Please do copy it and drop us an email. Thank you very much for listening, and I am very much welcome any questions about Mercury, about planetary science, and about diversity and inclusion. Thanks very much.
I'm here. I'm just trying to turn my camera back on. Thank you so much, Annie. That was absolutely fascinating. It was a real call for action for everyone involved, especially those sort of involved in planetary sciences, to make sure that we are actively contributing. Here I am back. There we go. Actively contributing and working to improve diversity in a field that so many of us are really passionate about. We have a few minutes now for questions. So if you have any questions, please add them into Q&A or chat on whatever platform you are on. We've got people monitoring those. Oh, a question straight away from Paul has been, what's the reaction been from the IAU to the open letter?
From the IAU. Well, disappointingly quiet, actually. Although saying that, I did I attended a conference called NAM this year, and through that managed to get in contact with the head of the newly put together diversity and inclusion board at the IAU. So I've met with them. They're super lovely and kind of aware that this is an issue now, which is great. They have spoken about maybe supporting this and the options I have with trying to change the conventions. Ultimately, what I want to do through these hackathons is, like I've said, reveal the state of diversity and representation. But with that, I think that could be put towards the IAU to try and encourage them to change the nature of the conventions. I think it's very important that we do not prioritise fame and recognition over contribution, and we make sure that the conventions that are set can allow any type of person to be named. So making it as easy, for example, to name features after a woman as it is a man. Currently, when you have to prove that that person is recognisable, is famous, that's very hard. You know, feminist literature has shown us that women always were scientists and artists and all these things, but their stories are not as well known, and so it is harder to demonstrate their contributions. So I personally don't think that should be one of the criteria for getting things named.
I mean, if you've gone through it yourself, what is that process like to actually have a feature named that you choose? Is it quite easy, or is it
first of all, it's extremely exciting. There's something so cool about, you know, choosing a name and it's going to be called that maybe forever. But for the Nairn crater, that's probably where I had the most difficulty. My first name was actually rejected, and that's because there was a man on Mercury who shared the same last name as the person I suggested, which is one of the issues. They can't have the same last name of any other feature on any other planet. And so there's
not just Mercury,
not just Mercury. No, this other person was a crater on the moon. It was a Stewart was the last name, and there was a Stewart crater on the moon. And Stewart, I think, spelt differently anyway, but whatever. But it does mean that there's this sort of de facto male occupation of space if it's operating on this kind of first come, first served basis. And so that one was rejected. My second name suggestion was Mary Brooksbank. Because I was thinking there's not going to be another Brooksbank. That's a pretty safe bet. But she too was rejected. Now, that's because the IAU, in their small print, say that you can't have any individuals of religious, political, or military significance. Now, again, they don't actually define what they mean by significance in any of these categories. But they rejected Mary Brooksbank on the basis that she had been quite outspoken about being a communist, which did anger me a little bit because of an issue. Actually, I've got time, I can go into it as well. For background, Mary Brooksbank is a poet and songwriter. She's the only woman to have her words inscripted into the building of the Scottish Parliament. Everyone else is a man, which I think is pretty poor. But so she's the only woman represented there. So she's really quite a big figure in Scotland. Now, she was rejected for being a communist. At the time, there was a crater called the Neruda crater. And in fact, one of the quadrangles, H13, is Neruda quadrangle, so he was quite well represented. Now, this Neruda was, he sat on the Senate for the Chilean Communist Party, so I would argue that that's fairly politically charged, but he did have this named after him. Additionally, and I hope it's okay to mention this here, he had self-written accounts of him being a sexual abuser, essentially, and so he was being well celebrated and perhaps not fully deserving of that celebration. Oh, Alice, you have frozen for me. I'm just going to check you can still hear me.
We can still hear you, Annie.
Cool.
Why don't you keep going? If we've lost Alice, I can take over.
No worries,
questions.
That's great. I was just hoping that I wasn't babbling on to no one.
Nope,
No,
you're
no
all
problem.
right.
Great. So Neruda, not particularly a great guy, perhaps not the kind of person that we want to celebrate forever in our nomenclature. And so a group of us at the Open University brought this to the attention of the IAU, who we managed to find a good way of rectifying the situation. They wanted to stick with the name Neruda because it appears in the literature and they didn't want confusion there. So we actually found two other artists with the last name Neruda and changed the origin. So it no longer celebrates Pablo Neruda, and in fact celebrates two Austrian, I think, composers who also have that surname. So it's a nice little shift and a really good example of IAU making some change. So I'm hoping that opens them to potentially more change.
Yeah, that's brilliant. Sorry, that was I am still here. Apologies. No, that's it. Yeah.
But I think I strayed away there from your question. At that point, when two of them had been rejected, I think I sent in a list of 10 women, all of whom I thought were pretty deserving. And of that list, the IAU came back and said 2 of those would be appropriate, and one of those was Nairn, which I think is lovely that she is represented. But because there was this catalogue of them being rejected, that kind of that was the first indication to me that perhaps it was a little harder to name something after a woman than a man.
Yes, without a doubt. I've got loads of questions I'm going to have to jump
Excellent.
to.
Cool.
So I've got, another one is, why have there been so few missions to Mercury compared with other planets?
What a great question. I don't know. I think it's brilliant. I think, well, when we consider the history of exploration, the easiest target and the longest looked at target really has been the moon, and that's because it's so close to us. Next to that, it's probably Mars because it has the whole potential of life. Mercury, certainly not a great place to consider looking for life. It's very it's not great conditions to live in, and so there's not that sort of appeal. So Mars is certainly a bit more of a target, and along the strain of looking for life, there's been quite a few missions now to icy moons, and that's because they have some of the chemistry that is good for life to be in existence. They have these plumes that have been sampled that they found, for example, amino acids and stuff like that in, and it would be very exciting to find life on those places because it almost certainly hasn't come from the same cedar that created life on Earth. If you did find life on Mars, there's no guarantee that it would be a different strain to life on Earth, because there's so much contamination between ourselves on Earth and on Mars. So that's a very interesting route of thought. And I suppose the final reason where Mercury might not be the perfect target is that because it's so close to the sun, it really is quite a difficult target to get to. This Bepi-Colombo mission has many gravity-assisted flybys, and it needs to have that in order for it not to just get carried away by the sun, which is what's happened to Mariner 10. It did those 3 flybys and then just kind of got swept into orbiting the sun. So it's not an easy target. It's not a target for life, but it's still great. It's still worth looking into, I think.
Not that you're biased in any way.
Not at all.
Definitely.
Not at all. But I think it's so interesting as an example of a planet that, yes, looks very much like our moon, but is so different. It kind of is an analogue for, well, maybe for Earth if we had no sort of erosion, because there's no there's not wind there, there's not water there. Every geological process that hits it there is so well preserved. So it's very there's a lot of reasons why it is exciting. I spoke about the interior. That's a really interesting thing. It might have this, or it does have a liquid layer to its core. It's got a magnetic field because of that. There's a lot of reasons why it's interesting, but an awful lot of reasons not to go there as well, unfortunately.
Yeah, it's not one that we're going to really be able to stand on and walk around and visit ourselves. It's not going to be a manned mission one. So
yeah,
really, so.
At the moment, heading to Mercury is very much a one-way ticket. But hopefully not too far down the line, there might be a mission to get a rover there. Including Bepi-Colombo, all the missions there have been orbiters. So it'd be very cool to get something on the ground.
Without a doubt, yes. I mean, we've only probed, 2 planets? It's Mars and Venus, isn't it? The only ones actually sent. So yeah, definitely something we want to see. My favourite question that has come through is, why isn't there a Lennox crater? Which more than happy for you to answer.
Well, I suppose one of my arguments would be that the reason we have some of the problems that we do in astronomy and with naming things is that people historically named things after themselves, which ended up being a very cis white male population naming things after either themselves or their cis white male friends. So that's kind of adding to part of the issue anyway. But like I don't know if I mentioned this earlier, but for a real person's name to be accepted, that individual does in fact have to be deceased. So, I mean, this is extremely morbid, but I am Annie Lennox, and I know there is another Annie Lennox who is much more famous than me and a little bit further along in life, but I don't think they're gonna be popping it anytime soon.
50 odd years, we never know. What I will say is it's useful to know is that while you can't name features, you can name like meteorites and asteroids after you work. And we've got
the university has one.
Yeah, so one of our postdoctoral research researchers now, not a student, he's not a student anymore, hasn't been for a few years. Sam Jackson has I think he's got an asteroid named after him. Right. I can't remember what it is. I'm just trying to look up and see which one it is. So you can get, I think you can get sort of voted for by your peers to have objects named after. So very jealous.
Cool.
I'm very jealous of Sam.
Yeah, totally.
I've got a couple more. I suppose this is a really good question that came in earlier is, do you feel that the scientific community has been receptive, supportive of your efforts to highlight these EDI issues? As a
general answer, yes. It's been overwhelmingly a great response, which is lovely. And I've had the opportunity to speak on this at some conferences and stuff, and it's been taken seriously, which is lovely. Unfortunately, there's also been backlash, and when you do receive backlash, that sticks in your head more than the positive comments, which is a real shame. I think it's especially hard because, you know, this isn't the mapping is my PhD. That's the reason I'm doing my PhD. This is very much has grown from a passion project, and so doing a PhD is hard. And then when you're doing something alongside that, that's taking a lot of, I mean, I love doing it, but it does take a lot of energy. And then to also be told by people within the science community that it's a waste of time, it's really disheartening. And I totally understand why not more people get involved in EDI, because it can be a little bit of a minefield. But Eleanor Favreau, who was with the Open University for a long time, once said to me that you have to have faith that you're annoying the right people, which has definitely stuck with me. I've had some great emails of people accusing me of reinventing the bicycle, and my favourite one, the sign off was "May your heart find joy in pure physics." Which I think is really entertaining. But yeah, you're gonna get a bit of backlash.
But that's how research is done anyway. I think this wasn't something that started with your PhD. This is something that has developed from the research.
True,
and this is
true,
how
very true.
discoveries are made all the time. It's how we have things that we didn't know that we were looking for, which we ended up finding. So I think it's definitely something incredibly exciting. I think that's sort of the end of my questions. We're finished on time, which is very, very rare for me. So what I'm just going to finish up by saying is once again a big thank you to you, Annie, for speaking to us about this, and for everyone else who's joined us. Hopefully you'll go away with some more insight into Mercury, which is fascinating, as we've now heard, but also a bit more insight into what goes on behind the scenes. I'm just going to finish by reiterating that Annie's got her hackathon on the 27th and the 28th of April. That is right, isn't it? Those are the right dates.
Yeah, that's it.
And if you want some more information, there's the email address for SPS Outreach is in the chat. So drop that an email and we can pass on any information to Annie. And Annie, you mentioned about Mars and about the sort of potential contamination. If you want to learn any more about the planetary protection that goes on, there's a whole load of research that we do at the Open University as well. We're hosting a massive conference in April. April, called COSPAR, and as part of that there'll be a public lecture on the 25th of April at Burley House, which might be really interesting for you to attend to. More information will go out about that later. And also in April we're having another lecture that will be hosted, so don't check our Eventbrite or check any of our socials for more information. But I'll leave it at that. Thank you very much. If you want to watch this then, this will be shared on our socials as well as a recording. So if you've got any more questions, I'm sure we can pester Annie to answer them later.
Absolutely.
But once then, thank you so much, and thank you for joining us.
Thanks very much for having me. Enjoy the rest of British Science Week.
Thank you.